Some technologies from the ancient world were so advanced, they really do seem like magic. For centuries, we completely lost the recipes. But now, modern science is finally starting to decode the secrets hidden inside these masterpieces. And we're going to start with a blade of pure legend.
And listen, this wasn't just some story people told around a campfire. When crusaders first came across these blades, they were facing a kind of steel unlike anything they had ever seen before. I mean, it was impossibly sharp, incredibly strong, and it was decorated with this beautiful, mysterious, wavy pattern.
So that's the big question, right? Were these ancient artisans just getting lucky, or did they understand materials on a level that we're only now beginning to catch up to? Well, it turns out the answer isn't magic at all. It was a forgotten science, one that was centuries ahead of its time.
Okay, so our first case study is this legendary metal. The original recipe was totally lost sometime back in the 18th century, and it left generations of swordsmiths and scientists completely stumped. They just could not figure out how it was made. And the difference between the two was, well, it was night and day. The steel they had in Europe at the time was fine, but it was often pretty brittle. Damascus steel, on the other hand, that was a true high-tech alloy. It had this ultra-high carbon content, which made it hard enough to hold a razor-sharp edge, but also flexible enough that it wouldn't shatter in a fight. For hundreds of years, nobody could replicate it. And the secret? It wasn't a magic spell, it wasn't some lost mineral. No, it was in a world that is completely invisible to the human eye. A world of tiny structures a billionth of a meter in size. And get this, the Smiths who perfected this process were basically using nanotechnology more than 400 years before we officially discovered it. That's just an incredible leap of genius through pure trial and error. So when scientists in Germany finally got a 17th century blade under a high-resolution electron microscope, they found them. Carbon nanotubes, and even something called cementite nanowires, perfectly formed right there inside the steel. These microscopic structures were the real source of the blade's legendary strength and sharpness. And the recipe just proves this was no accident. The Smiths used a very precise formula. They started with this special high-carbon steel ingot from India called woots. The process needed specific plants and ores that had trace elements like vanadium, which acted as catalysts to help grow these nanostructures. This was sophisticated, repeatable science. Now, this pattern of ancient materials science wasn't just for making weapons. It was for building entire empires. I mean, if you've ever seen the Pantheon in Rome, you've seen a structure that has survived for nearly 2,000 years. The secret isn't just the design, it's the concrete itself. The difference here is just staggering. Our modern concrete, especially if it's near the sea, can start to crumble in less than 50 years. But Roman harbors? They've withstood 2 millennia of crashing waves and have actually gotten stronger over time. For a while now, scientists have known part of the answer. The Romans mixed volcanic ash, lime, and seawater, and that chemical reaction formed a rare interlocking crystal called aluminal Lewis tobermorite. It's this crystal structure that made the material so incredibly durable. But that wasn't the whole story. You see, the final piece of the puzzle was hiding in plain sight. For years, historians just figured these little white chunks, these lime clasts, were just a sign of sloppy mixing. But a recent study from MIT revealed they're actually the key to the concrete's most incredible property. It all comes down to a technique called hot mixing. See, instead of mixing already hydrated lime with water, the Romans used quicklime. This creates what's called an exothermic reaction. It gets really, really hot. And that process forms these unique, brittle lime clasts that act as a kind of built-in repair kit. And here's how that amazing repair kit works. So, a tiny crack forms. Rainwater gets inside, and it activates those lime clasts. They dissolve, and then they recrystallize as calcium carbonate, which effectively glues the crack shut from the inside. It is literally an autonomous, self-healing system. And this isn't just a theory. Researchers actually recreated the Roman formula, cracked it on purpose, and then ran water through it. And within just 2 weeks, the cracks were completely sealed. The ancient recipe worked exactly as they predicted. Incredible. So you see, Damascus steel and Roman concrete, they weren't just one-offs. They're actually part of a much wider pattern of incredible scientific achievement in the ancient world.
a pattern of ingenuity that stretches across all kinds of cultures and disciplines.
Take the Antikythera mechanism, for example. It was found in a 2,000-year-old shipwreck. With this really complex system of at least 39 interlocking bronze gears, it was basically an analog computer used to predict eclipses and track the cosmos, a level of mechanical sophistication that wouldn't be seen again for over 1,000 years. And then there's this fascinating, and let's be honest, pretty controversial object, the Baghdad battery. It was discovered near Baghdad, and this 2,000-year-old artifact, well, it certainly looks like a primitive battery, a galvanic cell. But what on earth was it for?
The purpose of this thing is still really hotly debated. And while, yeah, it's exciting to think it might have been used for something like electroplating, there's just no archaeological evidence to back that up. A simpler and probably more likely explanation is that these pots were just used to protect sacred scrolls from the elements. So, what does all this mean for us today? I mean, these aren't just cool historical facts. They're profound lessons in science, engineering, and even sustainability from our most distant ancestors. The lessons here are they're powerful. I mean, imagine designing materials that last for millennia, not just a few decades. Building infrastructure that can actively heal itself. These ancient examples remind us that true innovation often comes from patient, careful observation, a skill passed down through generations.
And ultimately, I think this is what's so inspiring about it all. These ancient craftspeople, they didn't have electron microscopes or advanced chemistry labs. They had furnaces and hammers and generations of hard-won knowledge. They were the world's very first material scientists, and man, were they masters of their craft.
It really makes you wonder, doesn't it? If we've only just uncovered the science behind these really famous examples, what else is out there? What other marvels are still buried in time, holding secrets that could completely reshape our own future?